Good morning, afternoon, or evening, cats and dogs. Today's video will focus on graphing proportional relationships. So let's talk a little bit about how to address this situation. Recall that y equals kx is the form of the equation for a proportional relationship, where k represents the unit rate. We also call it the constant of proportionality. So if we want to graph a proportional relationship, that's the equation that it's going to look like. We can substitute numbers in for x and solve for y to find ordered pairs that are solutions to an equation. Then we can create a graph using the ordered pairs. This is getting us a really good introduction to something we're going to see much more of later. For example, a remote control car travels 4 miles per hour. The equation to represent this would be y equals 4x, since our unit rate is 4 miles per hour. So we can choose values for x, like 0, 1, 2, and 3, and figure out or solve for what y will equal. So when x is 0, 4 times 0 is 0. So when x is 0, y is 0. We can see that ordered pair right here. When x is 1, 4 times 1 is 4. And that means that when x is 1, y is 4. We can replace x with 2. So we do 4 times 2 to get 8. So when x is 2, y is 8. We can see that ordered pair right here. And finally, when x is 3, y will be 12, since 4 times 3 is 12. Now you can choose any values you want for x, although keep in mind we are talking about positive values in this case since we're looking at speed, miles, and hours. But you could choose values like 5 or 6 or 7 or 8 or 25 if you wanted to, but we try to keep things pretty simple here since we are going to graph it in just a moment. So when we go to graph this, let's start off with the ordered pair 0, 0. I'm going to highlight this in yellow. So 0, 0 is left or right 0, up or down 0. That's going to be this point right here. We also have the point 1, comma 4. So go to the right 1, up 4. You notice we counted by 2's on our y-axis here, but this was already set up. 2, 8. We go to the right 2 and up 8. Here's our point. Notice how they're forming a line, which will happen if it's a proportional relationship. And then 3, comma 12, we go to the right 3 and up 12, and that's going to be our point right here. So one of the things we'll talk about with proportional relationships is they're always going to go through the ordered pair 0, 0, or the point 0, 0, and they're going to be straight line graphs to show that we have a constant ratio or rate. Let's talk about the point 0, 0 and 1, comma r. We've already talked about 1, comma r. That's why I said in this unit we have a lot of concepts that sort of overlap. So let's look back at our example. A remote control car travels 4 miles per hour. That would be y equals 4x. Notice that when x is 0, y is 0. That's this point here and the work we had shown up above. That's the ordered pair 0, comma 0. Remember that every proportional relationship can be written as y equals kx. Since anything times 0 equals 0, no matter what value k is, we can conclude that every proportional relationship will have 0, 0 as a solution. So that means that the graph of every proportional relationship will pass through the origin, because if x is 0, y is going to have to be 0. So every graph will pass through the origin or 0, 0. It's also true that the graph of every proportional relationship will be a straight line. So it'll go through 0, 0, and it will be a straight line graph to represent our constant ratio or rate. Notice in our equation, when x was 1, y was 4. That's the ordered pair 1, comma 4. I'll slide back up here. That's the one we highlighted in green. We talked about identifying the unit rate from a graph earlier in this unit. So this point 1, comma 4 represents our unit rate. So remember, a proportional relationships equation is y equals kx. Since anything times 1 is equal to itself, we can conclude that when x is 1, y is the unit rate for any proportional relationship. So essentially this value in front of x is always going to be your unit rate. It's that variable k. The point 1, comma r representing some point in the graph, will represent the unit rate in any proportional relationship. So 1, comma whatever value it will be is always going to be our unit rate. And we talked about that previously in the unit, but it's something we're going to stress again here. All right, so here's a little bit of a summary we have in our graphs. What does the graph of a proportional relationship look like? And you have to draw these in. I kept these from last year so that I didn't have to try to redraw them back in using Smart Notebook here. But a proportional relationship is going to go through the origin 0, 0, and will be a straight line graph. So it could look something like this, where it goes through 0, 0, and it's a straight line, or as best as possible, because I did draw it on the smartboard last year. Or it could go through 0, 0. Maybe it's not quite as steep, or maybe it's even more steep. But as long as it goes through 0, 0 and is a straight line graph, we're good to go. Non-proportional relationships might look like something like this. Like this graph does not go through 0, 0. Is it a straight line graph? Yes, but it has to have both characteristics. So this does not go through 0, 0. It's not a proportional relationship. This one as well is not proportional because it's not a straight line graph. It wiggles a little bit. Most real life situations aren't going to be proportional because you don't often have a constant ratio or rate. This is a really good real life example where it goes up, then it maybe slows down a little bit, goes up a little bit more, slows down, then goes up again. So those two examples will be non-proportional. Really, the only thing you need to remember here is a proportional relationship is going to go through 0, 0, and it is going to be a straight line graph. So let's take a look at numbers 1 and 2. Looks like I forgot to cover up my solutions here. No big deal. Let's talk through these. It says to determine whether each relationship is proportional. So looking at number 1, I see that it goes through 0, 0. I see that it's a straight line graph. So I can say for question number 1 that it will be a proportional relationship because it is a straight line graph that goes through 0, 0. I don't have to say those in any particular order, but it goes through the origin, it goes through 0, 0, and it's a straight line graph. Now let's look at number 2, and my apologies for not covering up my solutions here, but no big deal. I notice that this graph right here is a straight line graph, but it does not go through 0, 0. So in this case, it's not going to be proportional because it does not go through 0, 0, even though it is a straight line graph. All right, let's move ahead to number 3. So this one, again, I forgot to cover up my solutions here, but no big deal. We're looking at Nick's earnings versus Todd's earnings on the same graph. So number 3, it says, which person's graph represents a proportional relationship between months and earnings? Explain your reasoning. Well, we notice that Nick's earnings, this red line here, is going to be a straight line graph that goes through 0, 0, whereas Todd's earnings are not a perfectly straight line graph, so will not represent a proportional relationship. So my explanation, Nick's earnings represent a proportional relationship because it is a straight line graph, while Todd's is not. Number 4, it says in both graphs, explain what the point 0, 0 represents. Well, we're looking at a time of 0 hours and earnings of 0. So basically at 0 hours, both Nick and Todd earned $0. So kind of makes sense. If you don't work any hours, you're not going to make any money. Let's look at number 5. For Nick's earnings, find and interpret the constant of proportionality. Remember, that's just the unit rate. So let's look back at our graph. For Nick's earnings, I'm going to highlight this in yellow. We're going to go to the right one and up. That's going to be this point right here that's highlighted in yellow. So that's 1, 50. So we know that Nick earns $50 per hour, 1, 50. If we wanted to find the same thing here for Todd's earnings, that would be a little harder because we don't have a point there. We could guess it's probably about maybe 1250, maybe about halfway between 0 and 25. But again, we don't know for sure. Number 6, we chose a different point, 4, 200. So we would have seen this also in lesson 1.6 for my Math 7 kiddos. For pre-algebra, you might have also seen this in some previous examples as well. So it's 4, 200. That's going to be, we're looking at Nick's graph again. So that's going to be this point right here. So 4 hours, $200. So it means that if Nick works for 4 hours, he's going to earn $200. The wording doesn't need to be exactly the same for what you write, although this is already on your paper, but we want to know that 4 hours, Nick is going to earn $200. All right, so again, didn't hide the solutions here, so my apologies for that. I can put my screen shade up, but it's not going to cover most of this. So we're looking at the number of chaperones compared to the number of students in this graph. So it says the number of students on the field trip is proportional to the number of chaperones, which makes sense. A lot of times there's a requirement for how many students can be with each chaperone. So number 7, it says to explain what the point 0, 0 represents. Well, that's 0 chaperones, 0 students. So 0 chaperones are needed for 0 students. You could also say 0 students, there's going to be 0 chaperones. Number 8, explain what the point 3 comma 30 represents. That's going to be this point right here, highlighted in yellow. That's 3 chaperones for 30 students. So 3 chaperones are needed for 30 students. Number 9, find and interpret the constant of proportionality. So remember, that's our unit rate. So 1 chaperone, so it's going to be 1 comma some number. In this case, that's 1 comma 10. I'll go ahead and label that here in the graph. So 1 comma 10 means that there are 10 students for every chaperone. So our unit rate, 10 students per chaperone. So it means we need to have 1 chaperone for every 10 students. So if we want to interpret this, we could say 1 chaperone is needed for every 10 students. And again, our constant of proportionality, that's just another word for unit rate. I'll go ahead and circle this for us. All right, let's move on to a few other examples. Being able to read and interpret graphs, I think, is something that's really important to be able to do. It's an important skill to have. So it says the number of pages copied is proportional to the number of minutes. It goes through 0, 0, straight line graph. Explain what the point 5 comma 200 represents. So I'm going to go ahead and highlight that here. It's going to be this point right here. So that's 5 minutes, 200 pages. So I can say it takes 5 minutes to copy 200 pages or something similar. Number 11, find and interpret the constant of proportionality. That's our unit rate. So that's going to be this point right here, which is 1 comma 40. It's always going to be 1 comma some number. So it's 1 minute 40 pages. So it's 40 pages per minute. So we can say 40 pages can be copied in 1 minute or something similar to that. All right, let's slide right ahead. So let's take a look at numbers 12 and 13. So the table represents the distance an elk ran during a period of seconds. Number 12 asks us to graph the relationship on a coordinate plane. In fact, I'm going to add my slide here so that we're not seeing that answer down below. But we're looking at time in seconds compared to the number of feet that are traveled or run in this case. So 1 comma 59, which is, by the way, going to represent our unit rate in this case. But I'm going to have to kind of estimate where that is. So 59 is going to be pretty close to 50, so I'm going to put a dot right there. 3, 177, so right 3 up to 177, so that's going to be about halfway between 150 and 200, maybe slightly above. Probably move that up just a touch. Okay. 6, 354, so that's going to be pretty darn close to 350, so put that right there. And then 7 comma 413, so 400 to 450 is 425, so probably about here. Now, if we try to connect these with a line, we'll go ahead and do that. Go ahead and make it a one-sided arrow here. It looks like it's probably going to go through 0, 0. It's kind of hard to tell. Let's extend that a bit. Yeah, it looks like it's going to go through 0, 0, but we can talk about how we know that it's going to go through 0, 0 here in a second. It says, is the relationship proportional, and explain how you know? Well, it's definitely a straight line graph, or at least appears to be, but it's also going to be a proportional relationship because it's going to go through 0, 0. The way I know that it's going to go through 0, 0 is because if this elk ran for 0 seconds, it's obviously going to go 0 feet. So it definitely makes sense that it would go through 0, 0 here. And I can pretty much tell it's a straight line graph. If you're not 100% sure, because maybe your dots are slightly off and you're trying to estimate their position, you could also figure out if it is a constant ratio. So you could do the ratio of y to x. So 59 feet in 1 second, 177 feet in 3 seconds, 354 feet in 6 seconds, and 413 feet in 7 seconds, and divide those, your constant ratio will be 59. So if you have a constant ratio, we also know it's going to be a proportional relationship. So we see a lot of different situations here that are going to overlap. All right, let's take a look at question number 14. So this, I believe, is our second to last question from the guided notes. Yeah, I just want to make sure we've got the right number of questions here. So number 14 says the distance Marissa and her family travel on vacation is proportional to the time spent driving as shown in the graph. So it's a straight line graph that goes through 0, 0. It says to find and interpret the constant of proportionality. So I'll highlight this in yellow. That's going to be this point here, 1 comma some number. Now, I don't know what that number is just by looking at it. I can see that it's above 50, but the good news is if I go down here to part B, it says to explain what the 0.001 comma 60 and 4 comma 240 represent. So I actually know this is going to be the value 60. How else could we figure this out? Well, if we do indeed find a point that's right on the line, like I'm going to highlight this one in green here. This point right here is 300 miles in 5 hours. 300 divided by 5 is going to get us 60 as well. So we know it's a proportional relationship, which means that ratio is going to be constant. But I can also use part B to determine that my unit rate or constant of proportionality is 60. So it'll be 60 miles per hour. Now let's explain what a few of these points mean. So 00 is 0 hours, 0 miles. So the family travels 0 miles in 0 hours. 1 comma 60 means that the family travels 60 miles in 1 hour. And finally, 4 comma 240 means that the family will travel 240 miles in 4 hours. All right, let's take a look at our last question, problem number 15. Olivia made a graph of the distance y in miles she can run in X hours. Olivia can run 3 miles in 0.5 hours. Which point on the graph represents Olivia's speed in miles per hour? So if we're talking about miles per hour, well, first of all, we're talking about a unit rate. So we know it's going to be 1 comma something. But miles per hour means we need to take the number of miles, which is 3, divided by the number of hours, which is 0.5. So 3 divided by 0.5 is 6 miles per hour. Again, we know that our unit rate, which is what we're talking about here, miles per hour, has to be 1 comma something, which means we can eliminate choice A and choice D. And since we know that she can run 6 miles per hour, the only choice that makes sense here is choice B, which is 1 comma 6. All right, this is something we've seen a little bit of previously in our unit. It's something we're going to continue to reinforce, but I do think being able to read and interpret graphs, no matter what career you go into, it's going to be really important. A lot of the bills you're going to receive as you become an adult are going to have graphs on them. So being able to read and interpret them, I think, is an important skill to have. Thanks for listening.